Welcome you back friends to CDS in Maths. Today we will discuss what is modulus of a complex number. So before going to the modulus of a complex number, let me remind what is modulus of a real number. So suppose x is a real number, then modulus of x is defined in this way. If your x is a positive, greater than 0 means positive, then mod of x will be x. If that x is negative, then mod of x will be minus of x. Actually, x negative, another minus will make it positive. If x is 0, mod of x is 0. Now for complex number, we cannot use the definition because complex number is a combination of a and ib, a plus ib. So this definition will not be applicable. So what is the definition of complex number modulus? Let's see it. Say a plus ib is a complex number, name given z. Then modulus of z is denoted by this way, like your real number, z inside mod, and is defined as, now this is the definition. What is the definition? Under root a square, what is a real part square, plus b square, what is b imaginary part, b square. So under root a square plus b square, a and b both are real. So a square is positive, b square is also positive. By real number definition, sum of two positive quantities is positive. Under root positive quantity is always greater than or equal to 0, which I explained in my earlier videos. Under root anything is always positive. So this is the definition of mod of z. Let's take an example. Say z is equal to 3 minus I root 2. Now suppose you have to find modulus of z. So I'll follow the definition. It is of a plus ib form. So under root real part is 3. So square of the real part plus square of the imaginary part. So here imaginary part is minus of root 2. So square. Root 3 square is 9. Minus root 2 square is 2. So 9 plus 2 11 under root 11. So this is a very simple definition. Now for us is more important is properties of modulus of a complex number. These properties are very useful. So I'll discuss this property here. For any complex number, say one complex number z, another z1 and z2, first property is mod of z is 0. If modulus of a complex number is 0, this implies that complex number itself must be 0. That is, real complex number 0 means what? 0 I can write 0 plus I0. So real part is also 0, imaginary part is also 0. So modulus of z0 means I can say real part 0, imaginary part 0, or complex number itself is 0. Second property, mod of z and mod of minus z if you multiply by minus, and again if you take the modulus, or z if you take the conjugate, again if you take the modulus, answer same, all are equal. Number 3, this is very useful. Z into z bar means conjugate of z. So z and product of its conjugate is equals to mod z square. Very important properties. Number 4 property, that mod of z1 into z2, modulus of product is equal to mod of z1 mod of z2. So modulus of product is equal to product of moduli. If there is a two complex number inside mod and between them if there is a into symbol, then mod will go to all the complex numbers. This way we can find using property. Now mod of z to the power n is equal to mod of z to the power n. Very important property. Now you see power is inside the mod, or power has gone outside. How it has gone? It has come from this previous one. Very simple, is a generalization of z to the power n is what? Z multiplied n times. So inside mod z n times. Now after that if you use the product rule, the product rule says mod will go to all the complex numbers. So mod z n times. So I can write mod z to the power n. So you have to understand that mod of z to the power n is equal to mod of z whole power n. That means power n from inside will go outside. Now next property is mod of z1 by z2. So if it is division, one complex number divided by another complex number and whole mod if you are to take, then you can use this property. You can take mod of numerator complex number z1 by mod of z2, provided z2 should not be 0. This complex number should not be 0 because otherwise this will be 0. Anything by 0 will be undefined. Now this is like your a plus b whole square, but is the identity. It is not mod, it is not a plus b whole square, it is mod of z1 plus z2 whole square. So is equal to mod of z1 square plus mod of z2 square plus twice real z1 into z2. So these few properties are not much important from NDA point of view, even from CBSE class 11 standard. So property 4 I explained. Here proof also given, you can see it very easy. And now let's go to the questions. This question came earlier in JEE mains also. Even it came also sometimes in NDA. CBSE also coming class 11 standard. So what is the information given? There are n complex numbers z1, z2, z3 dot zn. And information given is that they are all modulus. Mod of z1, mod of z2, mod of zn is equal to 1. And this is also 1. Reciprocal of z1 plus reciprocal of z2 plus dot reciprocal of zn, their mod is also 1. Then what is mod of z1 plus z2 plus dot plus mod of zn plus mod of zn. So here 1 plus. What is this value? So let's go with the given information. It is given that modulus of all the n complex number is 1. Now I am squaring all these. z1 mod of z1 square mod. So if these are equal, then their square will be also equal and 1 square will be equals to 1. Now here mod z1 square, I can write z1 z1 bar. Which property I have used? I have used this property. Z bar is mod z square. That means mod z square I can write z into z bar. Z into z bar is equal to mod z square. So mod z square is equal to z bar. This reverse way I am using. So z1 mod z1 square I can write z1 z1 bar using that property. Similarly, same property z2 z2 bar. Same property I am repeating here is equal to 1. Now z1 into z1 bar is 1. That means z1 bar is equal to, if I equate this first one with 1, so z1 bar will be equal to 1 by z1. Similarly, the second one, if I equate with 1, z2 bar will be 1 by z2. Similarly, z3 bar will be 1 by z3. Process continue. Zn bar will be 1 by zn. So these are the information we derived from the given things. Now with this mod of this, how much they are asking. So now mod of this z1 plus z2 plus dot zn plus. So this is equals to this. I can write first. How I have written the second property, mod of z and mod of z bar are equal. So these are all n complex number. Their sum will be again a new complex number. So mod of this whole is equal to mod of bar of this. Here 1 plus sign. So again another property says that conjugate property I told that z1 plus z2 bar means z1 bar plus z2 bar. So if we use this property for this n complex number, bar will go to all the complex number. Now z1 bar I can replace by 1 by z1. z2 bar is equal to 1 by z2. z3 bar is 1 by z3. zn bar is 1 by zn. And this value is 1 they have given. So what is the value of this? Answer is a 1. Now this another question is frequently coming in ND. It is from NCERT class 11 book you will find in the miscellaneous chapter. But there is the descriptive exam which if you are appearing descriptive exam then you have to show all the properties to get the answer. But here in competitive exam we need answer quickly. So what is then alpha and beta are different complex number and information given that beta modulus is 1. Modulus of the complex number beta is 1. Then what is the value of beta minus alpha by 1 minus alpha bar beta whole mod. So now let us do it using a short trick. Alpha beta different complex number. So I can say alpha is minus 1, beta is 1, no harm. My condition satisfied because beta is modulus of beta 1, yes. Beta is equal to 1 plus I0, a plus IB form. So mod of beta is 1. So I can say beta is equal to 1 and alpha, they are different, alpha is minus 1. Now if I put this value, beta I have considered 1, alpha is minus 1, so minus of minus 1 divided by 1 minus alpha bar. Alpha is minus 1, so alpha bar is also minus 1, beta 1. So 1 minus minus plus 1, the numerator is 2, denominator is 2, 2 by 2, 1, mod of 1 is 1, so right answer is A. So very shortly we can do it, but traditional method you have to show all the properties. Now next question, it came in day 1 2014. They are asking what is the value of this 1 plus I whole power 4n plus 5 by 1 minus I whole power 4n plus 3, where n is a natural number. Natural number. So natural number we know it start from 1. So I can assume any value of n. So for our convenience I am considering n is equal to 1. If I put n is equal to 1 here, so what will come? 1 plus I, 4 into 1 is 4 plus 1, 5, 9. And 1 minus I, 4 plus 3, 7. Now, here power 7, here power 9. So 1 plus I, 7, 1 minus I power 7, I am keeping together. And 1 plus I to the power 2. Now, here 1 plus I by 1 minus I, one complex number divided by another complex number. So division rule I will follow. I have to multiply up and down by conjugate of denominator. So 1 minus I conjugate is 1 plus I. So 1 plus I into 1 minus I will be 1 square minus I square, which will be 2. And numerator will be 1 plus I whole square because I have multiplied by 1 plus I up and down. 1 plus I whole square, if you open using a plus b whole square formula, then 1 square plus I square minus 1 plus 1 cancel plus 2I. So 2I by 2 whole power 7. And similarly, if you open this also a plus b whole square formula, it will be also 2I. So what happened? 2 cancel here. 2I power 7, another I power 8. I power 8 is 1. So 2 into 1 is 2. The right answer is A. Now this is another question. The information given is this. If z plus z cube is 0, then which of the following is correct? So let's start with the given information. Z plus z cube 0. So z cube, if I take z common from the left side, so 1 plus z square into z is equal to 0. Now product of these two factors 0 means either z will be 0 or 1 plus z square will be 0. 1 plus z square 0 means z square is equal to root over of minus 1. That is z is equal to root over minus 1 plus minus. Because it is a quadratic, so 2 value. So root over minus 1 is I. So I or minus I. So that is z value may be 0, z value may be I, or z value may be minus I. So there are three value of z coming. 0. If I take z0, then z I can write 0 plus I0. So, or if I take z value I, then I can arrange it in the form a plus I be 0 plus I. Or if I take minus I, then z is equal to 0 minus I. So you see these three in the three complex number, real part here also 0, here also 0, here also 0. So in all the cases real part is 0. So real part 0, real part greater than 0, real part less than 0, imaginary part 0. Imaginary part every time not 0, only here 0. So this A is the right answer. Now next another question, it came in NDA 2 2011. If Z is equal to 1 plus 2i by 2 minus I minus 2 minus I by 1 plus 2i, then what is Z square plus Z bar? So these are very beautiful question. So this is the Z, let us simplify it, convert it to the A plus IB form. So I have taken Z this, and from here 2 minus I, and in the numerator if I take I common, there it is also 2 minus I. If you take LCM it will be little lengthy, but if you think little smartly, then you see you can do it very comfortably. I have not divided this by this, or I have not taken LCM. What I did here, 2 minus I, from 1 plus 2i I have taken I common, then it will be 2 minus I. So 2 minus I, 2 minus I cut, it will be I. Similarly from second term you see, in the denominator I have taken I common. If I take I common, then it will be 2 minus I. Again 2 minus I, 2 minus I cancel. So here I minus 1 by I. And as I told in my first video, 1 by I is always minus I, and another minus, so minus minus plus 2I. So this is your Z. If you simplify it, it becomes 2I. Now we have to find the value of this Z square plus Z bar. So Z square, and you know property Z bar is mod Z square. This property I am using. So Z is 2I. So Z square will be 4I square, that is minus 4. And mod Z will be, mod of Z will be how much? 2, because 2I plus 0, so root over 0 square plus 2 square 4, 4 square root 2, minus 4 plus 4 cancel 0. So right answer is option A. Now next question, this is also NDA 2 2011. Also nice question, but people were confused, they given wrong answer. Very tricky type question. If Z is equal to 1 plus I 10 alpha, so Z is equal to A plus IB form, A is your 1, B is your 10 alpha, but they have given the information of alpha you see, that is important. Greater than pi, less than 3 pi by 2, that means your alpha, that angle in third quadrant. Then what is mod of Z? So let's see, as Z is A plus IB form, so I can find its mod. Root over of real part square, 1 square 1, plus 10 alpha square. 1 plus 10 square is sec square, and under root sec square is sec x. You see they have given sec x option. Many boys will make mistakes simply giving sec x. But you know that under root anything should be positive. Sec alpha if you write simply, then it is alpha in the third quadrant. You see, and third quadrant sec is negative, and modulus cannot be negative. So this is not the right answer. Option A is not the right answer. It should be modulus of sec square, root over of sec square is mod of sec x. It should be positive. So when it will be positive, if you take alpha is in the third quadrant, so sec alpha minus sec alpha will be positive, because mod value should be positive. So sec is negative in the third quadrant, so this is negative minus will make it positive, and these two are not the answer. So this is the right answer. Very nice question. So in my next video I'll discuss what is amplitude of a complex number. Till then, bye. Thank you.
If this video helped you, please like it and do subscribe the channel and share with your friends for latest update of the videos.